Okay, so let's now set up our instance file attribute properly. Let's come to our setup here. Now we want to recreate this path that points to our geometry on disk. So we want to do what we did before, but we want to do this for all our points, and we want each point to refer to its specific plant element. Now we don't have a variable that says what our plant element is, but we can use our variant that we set before to essentially drive which plant it's going to be. So let's just set this up now. Let's turn this off for now. We're not going to set this here. We'll keep it here for reference. But let's put down a new point wrangle. And let's start recreating this path. So first of all, let's create a new string attribute called instance file. So we're recreating the attribute we had before. And a string attribute is just an attribute that is a series of text. So it can be letters, numbers, words, as long as it's between quotes. And this is basically perfect for a file path. So it's a string at instance file. And let's start by just making this blank. So we're going to put quote, quote, semicolon. If we come to our geometry spreadsheet and I just type inst and then put star, we can filter everything and find our instance file, and you can see it's currently blank. So let's start building this up properly now. If we first just try and create our route to our proxies, essentially our hip location or $hip and then /rs proxy. Now let's also name this point wrangle as well. Set instance file, just so we know what it's doing. Okay, let's create a new string attribute and let's call this base path. And let's make that equal to channel string. So this is a string control. Let's call this route underscore proxy underscore path. It's always a good idea when you're making these channels not to have any spaces in it. It won't work if you do. So if you want a space, just use an underscore. When we create this, we now get our string control. And you can actually see it's replaced our underscores for spaces here in the name. So we can type into this, but let's also come up here and just edit our parameter interface. Let's select it, and let's just change its type to be file directory. So this is going to allow us to select a directory on disk. Let's just choose accept. Let's open this up and let's just come to our hip, to our RS proxy. There's all our plant folders. Let's just accept. So we've got hip/RS proxy. If I middle mouse click here, you can see this expands to what we had above. So let's add this to our instance file. Let's just make our instance file be equal to our base path. And now if I open this up, so far you can see we've got the first part of our instance file. So next we need to basically put a folder name that's going to be our plant name. And then we need to put the plant name again with a dot, then the frame number, and then a .rs at the end. Now to do this, we are going to essentially create kind of like a lookup table of all the names of our different plants. And then we're going to index into that using our variant, which goes from 0, 1, 2, 3, 4, to essentially look up what our plant is going to be. And we're actually going to use a string array variable for this. Now, an array is just a list of variables in order. You can have integer arrays, you can have float arrays, vector arrays. And to create them, you just use curly brackets and a comma separated list of your values. In fact, a vector itself is kind of an array. It's just an array of 3 float numbers. If you were to put down, let's say a point wrangle here quickly, you've probably done this before, where if you were to say attribute cd equals, you do open curly brackets, and then you're just creating 3 float numbers. So let's put 1 for red, 0.5 for green, 0.1 for blue. Close your curly brackets, And essentially you've created an array of just 3 floats, which is a vector. And this of course is driving your color. Now you can access the individual elements of your vector by typing attribute cd equals attribute cd dot r if you want to access the red channel, G for the green, B for the blue. But you could also do this by putting square brackets and just putting 0 for the first element, 1 for the second element, which is green, and 2 for the third element, which is blue. And of course, an array can have as many values as you want in this list, and so you can index into it just by using this sort of notation. So that's just the example using a vector and cd. Let's actually set this up properly using our string array. So coming back here, let's start by putting down a string. It's going to be called lm list, and we're going to put open and close square brackets, which means it's going to be an array of strings. Now we can fill this array by putting equals open curly brackets, and we're going to type in quotes, because this is a string, plant underscore a. I'm going to put a comma. I'm just going to copy this 4 more times, and this is going to be the rest of our plants. So we don't need the final comma there. I'm just going to close our curly brackets and put a semicolon. Let's just change this to be plant B. This one's going to be plant C. This one's going to be plant D. And this one's going to be plant E. So we've set up our element list here, and it's got all the names of our plants that we have here. Now we are going to essentially find, for each point, we can look up its variant, which goes from 0, 1, 2, 3, and 4. And we can just query that to get the actual name of the element itself. So let's create another string element, this time called lm. Let's make that equal to lm list. So we're just looking at the variable we just made, and then in square brackets, let's put I attribute variant. So it reads our variant attribute, close square brackets. And now we've essentially got a name for each of our plants, for each of our points. Let's just see this by coming back to our geometry spreadsheet, and now let's add this to our instance file. Now to add to a string, it's called concatenation, and you can do this just by putting plus and then your next variable. So we're going to put lm like so, and you can see we've now added our first part of the folder to each of our points, and each one is different based on the the variant. So this is super cool. So let's next put in the / and then we need to put the name again plus the frame number and .rs. So to put the / all we're going to do is do plus, and then in quotes we can just add a /. So now we've added that. Now again we need to add our plant name again, so it's going to be plus lm. This gives us our name once more. Now we need to add the dot, so plus quotes, and just put a dot in there. And now we just need our frame number. So let's create another string element here. Let's call this fr. Now we can take our current frame just by using the inbuilt variable called attribute frame, the capital F. Now Houdini always knows this one, and you can type this in here just to access the current frame number. Trouble with this though, it's going to error because attribute frame returns an integer, and this is a string that we want here. So we want our frame number to be converted to text. Now there's actually a really nice function you can use to convert your variables from integers or floats to string, and that's called sprintf. And if we just come to the help for that, it just says format to string like printf, but returns the result as a string. So it's going to return a string, and printf itself prints values to the console. So essentially this is going to take any variables we have specified and it's going to print them out as text. Now, depending on the kind of variable you have, you need to put a format in here. And there's a couple of sort of little formatting options here. So if you have a integer, this makes it a little bit larger, you can see that you can use %d or %i. If you had like an integer float, you could use %g. So depending on your thing you're trying to convert, you can use these different sort of attribute things here. So to actually use this, let's come here to our printf and we're going to use %d. So we put quotes because this is a string, %d, and then comma, and then attribute frame. We're going to close our brackets and then semicolon. And this almost works, but you can see while we do now have our frame number, and in fact we're going to add this to our instance file path. So let's just put +fr. We actually have our frame number, but it's on 2 decimal places, or 2, sort of like a padding of 2. Now if we look at our file or frame number, the original geometry, this has a padding of 4 numbers here. So we need to give this extra padding. Now, this is super easy to do. You just come to your %d, and in between the percentage and the d, just type 04, and this will give you a padding of 4. And you can put 06 if you wanted a padding of 6. It's a really cool way of just formatting things and giving yourself padding for things like frame numbers. So we're almost there now. We just need to add on to the end of this plus, and then in quotes, .rs, which is the suffix of our file name. Now it's always good to just double check this. Let's come to our one above, and we can see it's branch growth, rs proxy, plant A, frame number, and our extension. So just being triple checking here, this is correct, and this works correctly. We've got all our plant variations, and it's set based on our current frame number. Okay, so with that done, let's now go back to our main scene. This is of course going to instances out, which is going to be sent to our render instances geometry SOP. We've now got our points, which have our instance file attribute on it, which you can see there, along with all our other attributes. And if we were to come to our render view, you can see Redshift is now going to look up the geometry file for all of these points and load the correct one in. And there we go, there's all of our geometry loaded into the points. And of course we can go through this and it will load the various frame numbers. So this is super cool because now, of course, as well as all this, we have under setup in this instance file, we've got our frames specified by a single attribute here. So we could offset this, we could multiply this, we could fit this to a range. And this is essentially how we are going to control the growth of our geometry along the spline.